Make sure we are talking and we are streaming. Welcome, everybody. All right, we are live, I believe, and it says we are. It says sending data, and we got a few people online. All right, so without further ado, we've got 4 technical experts, technical business gurus in the industry. We probably have seen each of these faces at some IAEI meeting somewhere, right?
Probably.
Probably. Okay, so what we'll do, we have Ashley, Keith, and Mike, as promised to everybody. Let's do introductions first. So Ashley, always ladies first. Why don't we start with you? Why don't you give us who you are, your background, all that jazz?
Sure. My name is Ashley Bryant Kees. I am the product manager for electronic circuit breakers at Siemens. I have been with Siemens for 22 years now. Don't do that math. And I am happy to be here. Thank you, Tom.
Awesome. And then we've got Mr. Keith Waters, the Keith Waters.
Good afternoon. Good morning, everyone. So my name is Keith Waters with Schneider Electric. I'm the manager of industry standards, and I have responsibility for all of the circuit protection activity for Schneider Electric in the codes and standards space, including what AFCIs, which is our discussion topic today.
Awesome. Thanks for joining us, Mr. Waters. And we have Mr. Stone. Mike, take it away.
Thanks, Thomas. I'm Mike Stone. I work for NEMA. I am the NEMA West Coast Technical Field Representative, and I've been with NEMA about 10 years. I cover the 11 Western states for NEMA, and I'm actually based out of Northern California, so I'm trying to keep my head above water right now, but we're doing pretty good. And so, again, I've been with NEMA for 10 years. I was an inspector for 4 different jurisdictions in California for about 25 years before I came to work for NEMA. And before that, I'm not going to say how long ago it was, but I was an electrician by trade before that. So I do have field experience and a lot of experience inspecting. Thanks.
Wow. That's I mean, this is like a cream of the crop crew. And so you're out of, so let me just geographically, we've got California, Northern California with Mike. Keith, you're in
Kentucky.
Kentucky. That's right. I don't know why I was thinking Tennessee, because Ashley is in Georgia, Atlanta, Georgia. All right. So, and then I'm in Weirton, West by God, Virginia, from my basement down here. So my name's Thomas Dimitrovich, as everybody probably knows. I am director of codes and standards for Eaton Electrical Sector, and we've got Ryan Jackson in the house, and Matt Hermanson has already been chatting up a storm, putting a series of 4, I believe it's on one question. So we're going to get to Matt, and then we've got some welcome, and they're watching during their lunch break. So excellent. All right, we're talking AFCIs, that is arc fault circuit interrupters, right? Last time you looked. And so I think the journey for our discussion, and correct me where I'm wrong, we're going to do AFCI technology, and we'll talk about some of the history, the NEC, decreasing house fires. So we'll talk about statistics, all that good stuff. Some success stories too, which I think actually that's really important, because everybody talks about the fires, and we're going to talk about statistics, but nobody wants to talk. I mean, nobody wants to. We want to, but nobody gives a forum to talk about the successes. And then we'll get into AFCI compatibility, which I believe, and interoperability, which may be what Matthew Hermanson was talking about. His questions were around tripping and things like that. Some challenges from a state code adoption perspective, and troubleshooting, which is, again, another point that Mr. Hermanson is bringing up on his chat. And then we're going to talk about the future. We're going to go back to the future, and we're going to talk about new technologies, improvements, and building awareness, which is what we're doing here today, right? So what do we want to kick off with from a technology and history perspective? Where do you guys and gals want to go? What do you think? Talk about history?
Yeah, I think the history, and ESFI has a pretty good video on that.
Yeah.
That we might want to kick off with.
All right, let's do that. We were actually just talking about that. So I'm going to test my capabilities. And we're going to see if this works. Now this is, okay, so we're going to narrate this ourselves, right?
Mm-hmm.
Obviously, any one of these starts with a burning building because that's what we're talking about. What was that? 30,000 homes each year. How up to date is this? Is this relatively new? Is this like an average number?
That's an average number, and it's relatively up to date because it used to be a lot more. I think the numbers 10 years ago were closer to 70,000.
That's what I was thinking too, Ashley, because I remember, I know you and me and Mike and Keith, we've been doing this for a long time, working on the technology through all of the challenges, just like GFCI started. When GFCI started, there were compatibility issues and things of that nature. We were getting into all of that years ago, and I know those numbers were a little bit higher. 750,000. Is that 750,000 or 750 million?
750 million. That's the total. Yeah. The total in property damage.
Wow. So
Thomas, I will say, if you want to talk about history, when I worked in the field, it was way before AFCIs were even thought about. And I like to say sometimes that I come from the old school of AFCI, of arc fault detection, because when I went out on a trouble call, sometimes you could smell them burning. Usually you could finally open up a junction box and you had burned wires inside the junction box.
Wow.
And a couple of times I actually opened up a junction box and it was on fire as I opened it up.
Oh my
so
word.
That's the old time school of AFCI detection. So
well,
just for a little perspective.
You could probably feel it too.
Yeah. The other thing I learned this a long time ago, talking to a fireman. And I was trying to understand, and this goes way back in the day, I was trying to understand the technology of like just how fires start. And I've heard people say that, boy, you can have a wire cooking in your wall for a very long time. And I didn't understand how it didn't just erupt into flames. And he explained that that it doesn't have enough oxygen, that it'll cook in there for a while. And the moment it gets oxygen, meaning it has either built up to where it finally pokes a hole through something, and that's when because now his explanation was that the wood and everything in and around that space has been cooking for a long time. It's dried out, and then the moment it gets oxygen, it just goes up like very fast and very powerful. So maybe when you opened that box, you gave it oxygen too, and fed the fire, so to speak. Now, what's this? So this is showing the AFCIs and how it. Now, this is an AFCI circuit breaker going into a panel board, right? Or is that a regular breaker?
No, that's the AFCI.
Okay. I'm used to seeing pigtails.
Yeah.
What happened to the pigtails, Keith?
I think in this one they just ignored them for the video.
Or they're the plug-on neutral.
Or they're plug-on neutral.
Plug-on neutral. Now, what arc is this? Would you call that a parallel arc?
Yeah, that would be a parallel.
I have to put my glasses on, Tom.
Oh man, get those glasses on. I told you, Ashley. Got mine.
There you go.
There you
go. Okay, so then you also have, okay. Now
this is more common than you think. Yeah, the pressed against furniture, furniture pushed up against cords in the walls. We see this a lot.
Now, and this protection level is, I would say, arguably what the combination helped improve, because the combination type AFCI looks at the series arc in that SPT2 cord. Now, we could probably have a discussion whether that's a parallel arc or if it's a series arc and all of that good stuff in that wire. But based on that image, you have complete protection for the connected cords, because it does both that series arc and the parallel arc without the equipment grounding conductor being in the picture.
Mm-hmm.
Right. Yeah.
Oh, I like the way they do that. Look at that.
It's sort of interesting because of all the challenges, and we talk about what happens when something is damaged behind the wall, right? And in the home run or other areas of the wiring, and so that's that happens again more often than people think, and that this is what these hidden ones are very much what can sit and cook off on you when you least expect it.
Yeah, and you know what? I do have. While we're talking about this, I want to. Hopefully, I can do this because this one here. This shows a staple, and this is to your point, Keith. You have a staple on a conductor, which is could be behind the wall. In this case, it looks like it's in an attic or whatnot. But that staple was driven in too hard, and you can just barely see it. You could just see he turned the lights off, and they've got he's probably filming this with a flip phone, okay, based upon the image. But you can see how it is just sitting there, and there's nothing in the immediate area around that. He's going to turn the light back on again. There's nothing around that from a flammable other than the joist itself. And it takes a long time for that joist to, when you have a small arc like that, it'll take a long time for that joist to get hot and get dried out before it finally takes off with regard to from a fire perspective. But it's just sitting there very lightly, and it will just sit there and cook for the longest time until it melts insulation, and that could last for however long. I mean, no one's ever created anything like that and just let it sit there and cook to see how long that would take.
Yeah, exactly.
But I really found that video enlightening for me, at least. All right. Yeah. So we got behind the wall. You got nails. You got screws.
You have insulation.
Siri says she didn't understand.
You have insulation if it's an exterior wall right there, which is,
Oh yeah.
That's going to catch fire pretty quickly.
Yep, got the paper on that insulation. All right, so I think I like the video that ESFI did. ESFI stands for the Electrical Safety Foundation International, and Brett Brenner is the CEO of that organization, and they work very closely to educate. And these are just one of the many videos. I believe if you go to esfi.org, and you'll find ESFI's website. They have home safety, workplace safety. They do a lot of statistics. So just a little plug and free resource. Look at this resource library. There's cooking related house fires, winter storms. So there's a lot of really good information on ESFI's website. So if anybody out there has not checked out ESFI's website, they need to go to ESFI, Electrical Safety Foundation International, ESFI.org. All right. So, go ahead. You want to say something, Ashley? I know you do.
Well, because we were talking about the history, and I think it's important to note, because I love when I show up places as the AFCI guy, and they all go, "Oh, you created the AFCI to make money." And yeah. I think it's important to note where, the technology and the request for the technology came from. Meaning what? The CPSC, right?
CPSC data. And you know what? First, though, there was an organization, I can't remember, it was the it was an electronics group that was saying that the circuit breaker wasn't doing its job, right? It wasn't protecting the circuit. And the gentleman was demonstrating, basically cutting a wire and demonstrating that a thermomagnetic breaker wouldn't trip. And you know what? You know what I have, guys? I have.
So it was what you're looking for. It was the Electronics Industry Association. And the CPSC is who drove the requirements for AFCIs back in the mid-90s.
Yes.
They took it into while you're looking for what you're looking for there, Tom. That with the adoption of AFCIs in 1999 for implementation in 2002. So when we think about it, these technologies have been under development and in the works for quite some time. And what drove them was the CPSC fire data and the electronics industry themselves because of issues they saw.
Yeah. So this video is basically what that gentleman was doing. Now, this is a much safer. Let me just tell you what you're seeing. Down the bottom, you're going to see some sparks, and there's a razor blade cutting into an SPT2 cord, which is like your conductor cord that would go to a lamp or whatever. And in the video, this breaker here with the blue handle will be turned on. That's a standard thermomagnetic circuit breaker, and it will basically not trip as the arc is being drawn. So that's the power is being turned onto the circuit. The razor blade is cutting into the conductor, and that breaker does not open. And so they would go around and show that video. And then I know, you and me and others would sit and go, well, the breaker's not designed to do that, right? And then here's another one. This is a low level. This is your 5 amp series arc test.
The thermomagnetic breaker is not designed to do that.
Right. The thermomagnetic breaker is looking at current, which generates heat to bend a bimetal, or a large fault current to basically create the magnetic field and open the breaker.
Mm-hmm.
And that thermomagnetic breaker is not tripping on that series arc. So go ahead, Ashley. So you go back to the beginning. You got that group who's out educating.
Yeah.
And you got the CPSC.
And the driver was what we were talking about earlier, was the number of home fires. We all want to protect people in homes against fire, and how do we do that, and what are the biggest causes of fires? And one of the very large causes of fires is electrical fires. And so the AFCI technology was created over several years of trying to figure out if they could change some of the inrush current requirements for thermomagnetic breakers, which didn't detect the arc fault. So then we made thermomagnetic breakers smart in order to detect those arcs. And now you have 20-something years later, 24 years later, we have data that shows, just like we were talking about in the beginning, 10 years ago, there was 70,000 home fires a year, and now we're looking at 30,000. And I hope that number keeps decreasing. And that's not something that we need to worry about anymore for the future if we keep getting this technology. I mean, as we all know, AFCIs are only required in new construction, or if you're doing renovations, adding on 6 feet or more and getting a permit. But we always like to promote AFCIs in older homes as well. My home was built in 1960, and I put AFCIs in my home to protect my family.
Absolutely. I have them on my circuits as well. So NEMA was very instrumental in pulling the manufacturer. So here's what I like about this story, Keith and Mike, both, and all you guys. But the first reaction of, say, either a manufacturer or anybody, right? If I sat down and said, your installation is terrible for these reasons, or the way you did this, or the product that you made is not doing what it's supposed to do, the first gut reaction of everybody is to defend their position, right? Their product or their baby, right? Whatever it is. And I'm sure initially manufacturers, and probably appliance manufacturers too, because they were pointing fingers at a lot of people back in the day. Everybody was saying, no, it's not my product, not my product. But then we said, hold on. When you look at the data, CPSC gets involved and brings data to the table. What's kind of cool is, as a NEMA organization of manufacturers, we pulled together and came up with a solution instead of just continuing to continuing the argument or the debate. Yeah. Instead, yeah, the pointing of the fingers. I was looking for the right word, and that's it. So now we got a technology and the research. You mentioned research. I'm gonna see if I can do this. Whoop. Hold on. There it is.
Yep.
So this is the research data, right? And the trend that you were talking about continuously going down was right here.
There you go.
Yes, I can't move in any further. I'm trying. Oh, you know why? I know why. I have to open this up. I'm on the web, and I wasn't on the, there it is. All right, this I can blow up.
Yeah, and then we had, as you see the, you have bips and blurps around, as you move down that that particular chart, but it does, you do see that trend of reducing those fires, and that's important. And even beyond, there was additional research done beyond this report from UL and others. And one of the things that is, as we see the reductions in fires, other things were going on that made some of this difficult. And part of that was changing construction of furnishings, right?
Oh, yeah.
So when we start having the compressed wood and manufactured wood and things being used to build couches and chairs and other furniture, those were more flammable than solid wood furniture. So, there was some UL studies done on the amount of time it took to get out of a home once a fire started. You go from, that research showed that it used to be in the 18-minute range. Mm-hmm. And then, from the time of combustion to the time of the fire being starting to grow and expand. And in the more recent furnishings and stuff, we see about a 3 to 4 minute time before that same type of ignition happens. So, as we think about, protection from fire, and people look at the electrical malfunctions, that's becomes very much important, because the quicker you can extinguish something from happening and turning off that ignition source, you don't get down to that, how quickly does someone have a chance to escape a residence, right?
Right.
And so it becomes a proactive way of dealing with those fires.
Absolutely. Now, this is the whole picture of all homes. So this is another thing that I hear the questions. I've seen the questions where they'll say it's not significant enough of a drop, right? And they'll say, you went from 75 to 46, and when you look at numbers, you'll get the arguments and the debates on, well, are those new homes? Are they older homes? This is all of the housing stock. We can't differentiate. But the thing that we always have to remember is when we have AFCIs going into a structure, it's on new homes moving forward. It's on that new home. So if you take a look at just bedrooms, you're providing the protection for the circuits going to the bedrooms for that house, but none of the other circuits. And then we expanded to living rooms and to kitchens and to laundries and all these other areas later. But you have all of those conductors that are still out there that are in an aging infrastructure.
Yeah.
That will contribute to this. And the housing stock inventory is huge, Mike. It's huge.
Yeah.
If
I could make a comment along those same lines, and if I don't have the quotation for this, but with GFCIs, GFCIs, ground fault circuit interrupters, were first introduced in 1971 into the code. Mm-hmm. So they've been around for over 50 years now. And CPSC does studies on electrocution deaths. And they said that it took almost 25 years for the data, after the introduction of GFCIs, it took almost 25 years for that data to clearly show that they were saving saving lives, preventing electrocution deaths. So it would be similar to AFCI. It's going to take a long time. It has taken a long time, but we're seeing that data now and that decreased trend.
Yeah.
And just with GFCIs also, that there was a lot of existing stock that had been retrofitted with GFCIs in the meantime. So it takes time for this for these stats to show the effect. But excellent point though. They have been mostly in new construction and they're being retrofitted now. So we will be seeing those trends downward for sure.
Yeah. And now there's 140 million homes in the United States. 140 million. That's just based upon a quick search, right? We could probably go out to other resources and get a more exact number because we know. But you have a lot of existing homes out in just the U.S. And there's a lot of homes that aren't afforded AFCI protection, to your point, Mike. So it takes it in the fact that that the technology is making a difference in trending downwards is significant in my opinion, or that fact that you raised, Mike, that it's going to take a while because we know that we've never had a fire on an AFCI protected circuit. So if you had a circuit protected from an AFCI, especially when you throw GFCI on top of that, there is a very, very, very small chance. And I'll never say you can never have it because we know we're in the business too long to know that we've seen stuff happen that's crazy. But it is very difficult for an electrical fire to start because of that when you have these technologies. So just something to be aware of. I just got to stop these things here, make sure that these get out of the way. Man, I tell you, block. Just got to keep blocking.
Yeah.
Gotta love it.
So while you're blocking those, one of the other things that we've seen, right? We talked about originally the introduction of the AFCIs into the National Electric Code in 1999, and then the start of their installation in 2002. And as we've gone through the years, the code panel responsible for that have increased the locations and number of where those have been needed to be installed in order to protect those particular areas from fire. So we're at the point now that we have just a few limited areas that don't have that, and I will call it direct protection, because there's a high probability that some of those circuits are protected because they're attached to locations that have it required. But, we've got bathrooms, and garages and attics and unfinished basements and those things that don't specifically, require AFCIs, but could be covered under different areas. So we've seen that growth in that protection over the years from we went from the technologies, we went from the base to the combination unit, and now even potentially dual functions. But so we've seen a lot of that. And then you have some areas like the Commonwealth of Massachusetts, who went out and basically said all 15 and 20 amp receptacle outlets shall be protected by AFCIs. And so in the case of Massachusetts now, since January 1st of 2020, AFCIs have been required on all circuits, and based on the feedback that we've seen internally, what NEMA's seen, what the industry is telling us from Massachusetts, that's being extremely successful, and that industry is taking advantage of that state taking advantage of that protection. So it's not it's not a huge state, but it does give us the continuing knowledge and information about that. And we found I know we talked about ESFI earlier. They did a survey last year looking for activity and issues that might be in that area, and what they found in relation to AFCI was while they would get calls for tripping, when they got there it was either correct or there wasn't any other issue that was, related to the breaker tripped on thermal mag or something like that. So it's very interesting from that survey data, and as well as anything else. So anyway,
That's pretty cool.
Mm-hmm.
So, Gravity Mind, I like that name, Gravity Mind. Citing reviews of in-depth investigations, ES staff estimates that the inclusion of AFCI protection in circuit breakers could have prevented 50% or more of these fires. Wow. The U.S. CPSC memo on economic considerations, AFCI replacements 31003.
Wow.
That's significant. So that's what I'm saying. So if you think about an electrical fire in a house, doesn't have to happen. In my opinion, it doesn't have to happen. And now the only thing you're not protecting are, because AFCIs are available on 15 and 20 amp circuits, which is probably the majority of the circuits in a home. The 30 amps, the 60 amps, those are not, they don't have AFCI, but they now, because of the expansion of GFCI, they'll probably have a GFCI technology on them. So, and we've expanded GFCIs in many areas of the house. And other than dwelling units too. So, but between both of those technologies, what circuit in a house doesn't at least have AFCI or GFCI or both, right? You mentioned outdoor circuits, which is not required to have AFCI, has GFCI.
Right.
All right. Basements has GFCI. What else does, bathrooms.
Garage.
Yeah. And the garage. Yeah. So, when you look at the number of electronically protected, I'll call it, circuits in a home, it's very limited on what doesn't need to have some sort of technology on.
Yeah.
All right. So there was one other, there was a video too. I thought we were going to talk about. Do I have it? It was a fire victim, wasn't it?
right. I think that one was, there was actually a burn survivor testifying at a hearing, I think.
There it is. Oops. Hold on.
Good morning. Great to be back in the villages. Hope you all are having a happy new year.
Jeez, oh man. Hold on. I hit the wrong one. Or actually I hit. Well, let me come back to that. Let me get us 4 back on here while I try to fix this. Gosh.
Yeah.
Just got to hit refresh. How do I go back? Can't. You know what I'm going to do? I'm going to close that, and I am going to go back to the Word document because there was a link in there. All right, so that was the YouTube. There was the media files, research statistics. That was ESFI. There's the victim. All right.
All right.
There we go. You ready?
There you go.
Oh, yeah.
I'm not going to hit fast forward this time.
I will live with these scars, physically and emotionally, for my entire life.
Rebecca Johnson is a burn survivor of an electrical house fire. 50% of her body is covered in 2nd and 3rd degree scars.
It was early morning and a spark set my bed on fire, which set me on fire.
She says this fire could have been prevented with a certain type of circuit that detects faulty electrical wiring. Now, these circuits are mandatory in all bedrooms and bathrooms. And in 2014, the National Electric Code required these circuits in kitchens and laundry rooms as well. However, Florida didn't immediately adopt that policy. The fire marshal in Alachua County says most people can't even tell if their home has a circuit that could detect faulty wires or not. Today, the Florida Building Commission opened up that topic for discussion again, but the Homeowners Association was allegedly against adding these circuits to kitchens and laundry rooms.
The Home Builders Association is always looking to cut costs in building a home. And so that's basically what it boils down to, is the cost. And even using their high estimate of $200 per home, that's a pretty insignificant cost when you're talking about the kind of life safety at this level.
But the Florida Building Commission voted today, after listening to Rebecca's story, to put these circuits in all kitchens and living rooms.
They can keep families safe. Every year we see new survivors coming to our camp that I'm a part of, and it's sad. because I know that they could be prevented.
A unanimous 9-0 vote means that Florida will require new homes to have the circuits in these rooms. Reporting in Gainesville, Marissa Sarback, CBS 4 News.
For me, it is a good.
Wow. That's, it is very powerful when you have someone like that speaking at a hearing or at some of those events where we do code adoption and whatnot. So that was 4 News. I guess that was Florida, right? Because we had we had a Brian Holland sighting.
I saw that.
Brian Holland is one of your counterparts, right, Mike?
He certainly is. I just emailed him this morning on a couple of things.
Excellent. That's excellent. All right.
So one of the things, Tom, that we might want to look at as we move forward, we might want to show some of the success stories that people talk about, applications or specific issues where AFCIs have been successful, and a lot of people talk about where that happens, right, and what caused it. We talk about presentations, we do surveys, we do the investigations when they get in the field, but what actually shows up when we're doing those investigations. So one of the things that we can look at here is these are examples where AFCIs found a problem. So the particular one you're looking at, bounce back to that one. There you go. This particular one here was interesting because it was a home in Texas, and the AFCI kept tripping, but the contractor couldn't figure out what was going on. The homeowner was concerned. The home builder so there was multiple visits trying to figure out what was causing the tripping activity. And so the first thing to understand that when a breaker trips, there's usually a reason it's tripping, right? That's its job. If it sees a problem, it's supposed to trip, right? So what they ended up doing is they contacted the manufacturer of the AFCI, which in this case was our company, and we sent a services person out to work with the electrical contractor with some equipment, and we identified from that visit that there was the AFCI was tripping based on a problem between neutral and ground conductors. So it was seeing an arc fault that could cause a fire. And it was in the wall. So there was a lot of activity here. And finally, the home builder was like, if this is where it is, you need to open the drywall and go fix it. So the drywall was removed. What you're looking at is a picture of what they found. So there was 2 nails in the area that had been driven and didn't make it, into the stud. And it actually, the second one drove right through the Romex, and there you go. Now you have it's sitting there arcing.
Yep.
And this is a case that a fire would have started or could have started in sometime into the future, but the AFCI did its job, right? It identified the arc, it tripped, and basically, if that AFCI had not been there, the potential for this to be a fire at some period of time in the future was highly probable. And so this is why they're there.
That's exactly right. Yeah. And like you say, that could persist for a very long time and no one would know it. So this is available, this document, it's a PDF, but it's really a PowerPoint, but this is a PDF that we can download off of AFCIsafety.org. So if you go to AFCIsafety.org, let's do that. Let's go to AFCIsafety.org, AFCIsafety.org. You'll see this page. You go to, I believe it's in, I don't know if it's in multimedia. Yeah. Multimedia. You'll see some videos to help you understand what a parallel arc, series arc, all this good stuff. Then you have the presentation, arc fault circuit interrupter success stories, and there's a couple good brochure information in there. So let's go back to this document, because this one, there's actually a whole series of video. I have a whole series of, we interviewed, this one came into to us from an Eaton perspective. And we had a frustrated homeowner. What's interesting about this one is that the homeowner went to the contractor, called the electrician, and his first electrician apparently had to go into the hospital because he was sick for something like that. So he called someone else. They came in and they said they were going to replace the AFCI with a standard thermal mag breaker. And he goes, no. Yeah, he says, I have to sell the house. He says, an inspector is going to find that. And so they changed the receptacle because it was a bedroom circuit, because he was on the code that was just for bedroom circuits. They changed the receptacles because they said you needed heavy duty receptacles. They changed the light switch because they told him you need heavy duty light switches. And then he says they did a lot of work. And then finally the original electrician came back and he explained to him the frustration that he was having and then he called us. And Joe Fellow, a guy that worked for me back in the day, he took the call and he worked with the homeowner, worked with the electrician. The electrician said that when he went in the attic to see where the circuit goes down to the light switch, that he smelled gas. And there was like 2 or 3 gas leaks he found in the attic next to where this arcing was going on, because what they apparently did was they drilled down through a gusset plate. And that, where you see the tape, is where he was trying to fix it, because he was like, I'm just going to wrap this with tape because there was exposed conductors. But then when it didn't work, and the homeowner said, no, just replace the circuit. So when he replaced the circuit, let me get back up here. When he pulled the circuit out, the conductors that were in the wall, what they did was when they pulled the conductors down to the panel board, it shredded the outer sheath and some of the insulation, and it just was sitting there in the wall arcing. And the homeowner, there's a time when you start to question everything. Right. You question the breaker, you question the guy on the phone, you question the person in your house, and you question yourself on, am I making too big of a deal out of this? And when we found this problem and he replaced it, he wrote us a beautiful letter thanking us for the technology. And in his mind, and he's probably right, I can't argue, I don't know, we don't know if he's right, but he said he felt like he saved his family's life, and he may have, right? So This one was near and dear to my heart. So we got him on video. We did a 4-part series where he walked through everything that he was experiencing and then the final solution. It was really eye-opening.
Wow. It was. And if you don't mind, Tom, I'd love to take this moment to make sure everybody is aware that all of us manufacturers, have excellent tech support teams. Excellent tech support teams. And the reason that we have invested in these tech support teams is so that we can help the industry, homeowners, electricians, home builders, inspectors. Our whole job is to help with any troubleshooting, with any education, with anything that y'all need in the field. We are here and we want to help. And so that tech support number on the inside of the load center for all of us, call that number. We have great resources and they can walk you through troubleshooting. And if we're not able to help you over the phone, then it gets escalated, in different ways. Some of us have troubleshooting tools that we'll send you. Some of us have, guys that will send you, whatever it may be. But I do want to make sure everybody is aware. And on that AFCIsafety.org website, there's also a list of all of the manufacturers and our tech support phone numbers. So I think you can go to professionals. I think you can go to homeowners too. I think under any of them. Yeah.
So under professionals and homeowners, there's the unwanted tripping, right? So and there's useful leaks. So you can put your information in to be contacted, right?
Right.
And where is there's the why, there's the what, there's the white paper, fast facts, professional state adoption and tips, homeowners, why you want cost overview, news, and then multimedia. Where is our links? Where's our about? Is it about us? I thought we had phone numbers on here somewhere.
We do. I'm looking as well. Let's see if I can find them.
Cost overview tips. Let's look
And
at
while,
tips.
while that's going on,
There
if
it
for
is.
some reason that you have an unwanted tripping issue or a tripping issue that you think potentially you can't figure out what's going on, there is on that website, there is a selection that you can make and load the information in on the situation, and someone will contact you about solving that issue, whether it can be done over the phone or needs to have someone come into the field. That can be done. And so we definitely recommend you use that if you think you have a problem that is you're struggling with what's going on. So feel free to do that as well as contact any of us.
Yeah, and if you go, and it's under the tips. So it's professional tips, homeowner tips. We should put about us, and we should add a page to there, and all that good stuff.
I will make a note of that.
There we go. Yeah, see, we got the right person on the phone, right? We got the person. Okay, so let's do this. All right, so we talked about sort of the stimulus. We talked about the statistics. We talked about the fire. Sparky 1500 says, my life was potentially saved by a GFCI about 10 years ago. Now, this is GFCI. I was on an aluminum ladder when the old metal house drill, we all seen those, shorted. He felt a brief, mild shock, and then the GFCI tripped. That's pretty cool. We got a success story for GFCIs. That's cool. Yep. And if anybody has a success story for AFCIs, please share that with us. All right.
Yeah.
So.
Yeah. So one of the things that we get a lot of questions on currently are AFCIs and protecting the branch circuits that have appliances on them.
Yep.
And and so we get a lot of I'm not going to call it noise. A lot of discussion in the industry about appliances having issues, right, with AFCIs.
Mm-hmm.
So over the 20 years that we've seen appliances installed, if we look at, I recently did an analysis from 2014 on. So that was when kitchens and laundries were added to AFCI requirements. And so if you go and you look at the number of new homes built, new apartments built since 2014, you go to the individual states and look at the states that when they adopted the NEC to bring those in, and you take out ones that may not have, and you take all of those numbers that you can find from somewhere else. And then I went to a statistics company called Statista that does surveys on what percentage of homes have appliances and what appliances. So if you pull that data out on, like 83% have refrigerators, 56% have dishwashers, and you add all of those in for all of those different appliances, and then you add up the appliances, you find that over 60 million appliances are installed on branch circuits that are protected by AFCIs today.
Wow.
So, and that's a minimum number because you have over 60 million.
60 million.
Yes. So you have over 60 million appliances on branch circuits protected by AFCIs. And, that doesn't include, that's a conservative number because it doesn't include older homes that have been upgraded, people that go in and add AFCIs to their existing homes were not required, and so different things. So the number itself, the minimum number is 60 million. So if you think about that, there's 60 million homes in the U.S. or 60 million appliances being protected by these circuit protection devices. That's a lot of appliances.
Yes.
If there were major issues with something of that size, the CPSC would be involved. People would be doing recalls. All these things that happen. It's really you have to think in terms of context when you start looking at people, and making sure that facts are presented versus rhetoric. And so I bring that up because that's something that I calculated and used none of our data, right?
Wow.
That was all external data that I went out and found. The NEHB data I obviously had to go get for the construction, and the same with the statistics and the state adoption. So none of that had anything to do with us as a manufacturer. It was all data that's readily available.
Yeah.
Anyway.
And we've seen some of those issues before that were spread wide, not with appliances per se, but I think we have a success story or two on the website that shows where there were multiple different instances of AFCIs tripping on a light fixture, I think. And so CPSC got involved. That light fixture ended up being recalled because there was an issue. So, like Keith said, 60 million applications. If there were a lot of issues, CPSC would be involved, and there would be something.
Yeah,
right?
you got like so to your point, CPSC did a recall on home theater speakers. I that's new. I've not seen this one, so I'm glad to see that the AFCI task force is growing these examples. There's your ceiling mounted light fixtures recalled, and then there's another one, ceiling mounted light fixtures that were also recalled. So these examples. Now we had Matt Hermanson had some like a 4-part question right in the very beginning. And he was asking, and I think it's, in my opinion, he's talking about in this case, he's talking about on one circuit causing a breaker to trip on a different circuit. So it's almost like you said it earlier when we were reading this right before we went on. I think it was I think you made the comment that it's like crosstalk, right?
Yeah.
And so the interesting thing that I would say, Matt, I know that all 4 manufacturers, and I know there's a 5th manufacturer, there's 5 manufacturers of AFCI devices, right?
Right.
We have 3 of them represented here, but there's 2 others, NEMA members as well. And that the breaker has a job of looking downstream. It can't look back. It shouldn't look back, right? So what we typically would see in any of our designs, and everybody does it different, I know that, is that we will see the technology will put filters in so it can't see what's going on upstream. Now, here's what I will say. In my house, I had a couple circuits trip, and I couldn't figure out what it was because it took out, I think these were just GFCI protected circuits. So they weren't AFCI. It was at the time, it was before I put my AFGF breakers in. But I had ground fault circuit interrupters on every circuit in my home. And I had 2 breakers trip. One was on my stove upstairs, and the other was a 20 amp going to, I don't know, something else in the house. And I reset them. And then they opened again, and then they wouldn't close. And I couldn't figure out what the problem was. And here was a problem with my stove, and it was wreaking havoc in the entire distribution system in my house because of what was going on in the stove. And I don't know exactly what was going on, but it was causing the GFCIs to react and other things. So I was having I would see, like in my house, the lights were going, right? We're giving that visible indication that there was some electrical issue going on in the house. So I know that when you have an event or a problem on a circuit, it can, and this is just from my perception, my what I've seen, I believe it can wreak from a voltage, because when you change voltage impacts everything. It's like when we talk about a surge event. Right. When you have one surge event, because it's a voltage event, it impacts everything. When you talk about like current harmonics and things like that, the current harmonics will stay with the load. But a voltage type of event, a current event stays with the load, a voltage type of event impacts across the board. So if you impact voltage, you can impact across multiple circuits. So if there's some sort of voltage event that's causing a problem or identification of a problem in another circuit, I don't know. It could be something of that nature, but he's talking about a CAFCI combination.
Yeah, a combination.
Be a combination.
Just like you were talking about in the beginning, protects against series and parallel arcs. Right. And I mean, if we've learned anything over the years, electricity can be a little bit wild, right? You've got crosstalk, which is what he was talking about, kind of talking back onto the neutral. You've got conductance, which I think is probably what you were seeing, Tom, in your house. If you've got two wires running together, you can get conductance from those. Mm-hmm. There's so many different things that can happen. And I mean, I know personally, I went to a home where every time they turned on the stove, the breaker in the master bedroom would trip. And so we pulled that stove out, and that stove just happened to have bad infinite switches on the back of the stove. And where those switches were switching and burning, it was black, it was charred, there was charring on the wall. And that circuit ran right next to the master bedroom circuit. And so that arcing, the stove's not on an arc fault breaker, right? Right. The arcing from the stove somehow transferred to that master bedroom circuit and was causing that breaker to trip. So was it annoying? Absolutely. Did it probably save somebody's home from burning down? Probably. I think so. Yeah. So that goes back to the call us, we want to help. The phone calls I get from some of my guys are like, my breaker tripped, fix it. I'm like, well, your breaker is actually designed to trip. Let's fix what's tripping the breaker. Yeah. Right?
Yep. That's the challenge, right?
So that nobody gets electrocuted, so that there's no fire. So all of those things, these are safety devices, and they're safety devices for a reason, because we want to protect our homes and our people. So
absolutely.
Yeah. So one of the things, Tom, just before we finish up, I wanted to make sure that we thanked all of the folks in the industry, from electrical inspectors, electrical contractors, the fire service, doctors, nurses, burn survivors, all of those organizations and folks that support AFCI technology and understand the very things that we've been talking about. And so we want to make sure that we pass that along to the folks on the watching the video, so they understand that it's not just manufacturers out there supporting these technologies and understanding what's going on. So just to make that clear as we start to wrap up. So
yeah, and that speaks to, like, where do we think the future of AFCIs are going? I mean, we want to end on a note. What is it? What's the next chapter in AFCIs?
I think I think we'll continue to see expansion to the few areas that maybe are left in the home. We talked about Massachusetts, but other states moving that way as well, along with the NEC. But I do also believe that as we work through the product standards, as we see opportunities to make the technologies better and being able to address these potential fire ignitions, I think that'll continue to help the products improve.
Yeah, 2023 just introduced the 10 amp circuit.
Yeah.
So we don't have a 10 amp AFCI yet, Mike. We got to get all the NEMA brethren on board, and
I'm working on it.
You're working on them? Yeah.
I think that's actually an interesting concept. I would have never thought we would have 10 amp circuits, but with all of our energy efficient lighting, it makes sense in a lot of ways. Yeah.
Yeah. And most of those, you may not have to GFCI protect the lighting in your living room, but you definitely have to AFCI protect the lighting in the living room. And if you're going to put something on a 10 amp circuit, it's probably going to be lighting.
And just from personal experience, a lot of the arc faults I ever fixed were on lighting circuits. A lot of them. Yeah.
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 A lot of splices in those branch circuits where they go bad.
Yeah. So Ashley, what do you think the next chapter is?
Well, I agree with Keith. I'd love to see expansion. I mean, yes, we get complaints, but above the complaints, the success stories and all of the good that has come from these safety devices. I'm grateful to be in this industry. I'm grateful to be associated with these devices, and I'm excited to see the expansion into the rest of the rooms of the home to protect people.
Yeah, and my head keeps going back to existing homes. I think that the existing housing stock is a contributor to the fire statistics. There's a lot of homes out there, and the challenges with an existing home is the fixing the existing problems, which you would think. Part of me, I completely understand. My brother's house was a 50s home. We put AFCI technology in that home, and we found I think 3 circuits that had issues. One was a bathroom circuit where they shared the neutral, right? There was 2 shared neutrals. That's what it was. One was in the bathroom. They took the neutral conductor, they took the equipment grounding, the neutral, and they wrapped it around the equipment grounding conductor. Okay, and it was a metal sheath conductor. It was the MC cable with just a hot and a neutral. So they bonded everything, and they took the sheath was carrying the current, and then what they did, the second one was they had a circuit that came down to the basement, and there was a big gang box, and all we did to fix the problem there was we pulled all the light switches out, separated all the neutrals, and then we just tied the neutrals together that needed to be tied together and put everything back together again. But the third one was the circuit he used for the Christmas tree and all this other good stuff. It was on an outside circuit, and we could not get it to hold at all. And it was because the insulation had fallen off of the conductor in the wall. And literally when we pulled it out, when we moved the wire, the insulation would just crumble off.
Yeah.
Because of the humidity and the changes of temperatures over the years. It was built in the 50s. So we pulled a new circuit for that one. But he was, he's an engineer too. So he was like, he was all in as the electrician, which we both drove the electrician crazy. Right? You never want to work in an engineer's house because they'll just drive you buggy. So, but we fixed and found all 3 of those, and the guy who was at the house was just sharp as a tack. So he was awesome. But those are, I think the existing housing stock, it can be a challenge fixing the problems, but if there are a problem that needs to be fixed, then that's also a threat to your structure, your investment. So
yes,
it can be, though, very expensive to pay somebody to troubleshoot. So, but hopefully the troubleshooting side, and Ashley, I'm the biggest seller of that portable unit you have. What's it called?
The IntelliArc. We have a new one coming this summer. Stay tuned.
Stay tuned. Oh boy, I tell you, those technologies to help troubleshoot circuits are absolutely awesome on the market. So,
thank you, Thomas.
Thank you. Okay, so where do we? It's 1:03, so we've been on for an hour. What do we want to do? How do we want to close this up? We want to do some closing remarks, and then Matt is in another class now, so he moved on. Raphael. Matt, I disconnect everything. There was a plug in the receptacles in the circuit, and it's just lighting causing it. So he had an issue with lighting. Gravity Mind is contributing. It can't trip on inrush currents, normal operation, arcing, non-sinusoidal waveforms. So he's talking about the EM and RF interferences and things like that the standard helps us with. There was a question about LED lighting compatibility.
Yeah, it's the one that Raphael's talking about there. So if you continue to have that problem, Raphael, what I would make a suggestion is either contact the manufacturer of that AFCI directly, or load information into the unwanted tripping
Right. AFCI
portal
safety.
with that AFCIsafety.org, and let's get some help for you from one of us or those that aren't on the call to help you provide some additional help with that troubleshooting. So
Absolutely.
that would be my suggestion to kind of keep your frustration level down.
Yes.
Agree.
www.afcisafety.org, and they can go into the troubleshooting and add that. And I would encourage everybody, even be one and lock and step with your manufacturer. If you deal with any of our products, if it's an electrician, is go into a troubleshooting call. I don't know about you guys. I don't know about Ashley and Keith, but I know what I've heard all of us say. So I know you guys say it too. Call us. We'll give you those little tips and tricks to look out for, so that when you get that first call to go out to that site, you know what to ask and document to help reduce your time invested. That is critical, in my opinion.
Agree.
All right. Last remarks. We started with you, Ashley, and we will start with you to close us out. So give us just a brief little remark.
That's a lot of pressure, Tom.
You're on the stage.
No, I just want to say thank you for having us. I enjoyed it, and thank you everybody for your time. I really appreciate it. And I guess my leaving remark is, please contact us if you're having issues. We want to help. And we want to keep these in the fields to continue to protect homes and people.
Amen, sister. Amen. Mr. Waters.
Yeah, so I'll follow Ashley there with the same thing in terms of thanks for having us, and thanks for everyone who participated in the program, watching us have our discussions, and ask as you work through and work with AFCIs. You know, if there's any questions or anything that comes up, feel free to let us know, and then also to get involved. One of the things I would ask each of y'all to make sure is that you get involved in electrical safety, whether it's through your local inspectors meetings, your local state code adoption, or whether you want to play on the national stage and provide public inputs or comments to the National Electric Code. As Tom mentioned earlier, the 2026 National Electric Code is beginning its process with the public inputs now open.
That's right.
Feel free to view that. Anyone and everyone can submit their suggestions. So thank everyone again, and appreciate you taking the time.
Excellent. Thank you, Keith. And Mr. Stone, I presume.
Well, I'll just say that one of the main parts of my job at NEMA is I get involved with a lot of state code adoptions and also local adoptions. And I've over the last 10 years, I've just heard a lot of feedback on a lot of different electrical safety issues in the National Electrical Code, and AFCIs in particular. And I'm convinced that AFCIs are just one of the biggest innovations that have come along that's going to help electricity be used safely. So it's an important aspect of a safe electrical system, especially in our homes. Thanks.
Yeah. Thank you, Mike. And there's a lot going on in California. I know you're in the front of everything. So,
well, yeah.
Yeah. We appreciate what you do.
Sure. Yes.
What?
And by the way, in California, there has not been any question about California. This is a shout out for California. We adopt the NEC with virtually no amendments whatsoever.
Wow.
And I think we're pretty safe out here.
That's great. And why don't you just there are 4 NEMA field reps, right?
Yes.
You, Brian Holland,
Jack Lyons, and then Tim McClintock was until yesterday was his last day. He was our Midwest field rep, and we are actively recruiting right now for a new Midwest field rep. So if anybody online is interested, please shoot in your application.
Absolutely. So excellent. And all right. So and I thank you, each of you, for coming on. I enjoyed the discussion. And doesn't an hour go fast? Tell me.
Yes.
Always. Yeah.
Man, I'll tell you, it's just, it flies. And then you feel like all those things you wanted to say, you didn't say. So,
Yeah.
but hopefully we will do this
Going through my
again.
notes, checking stuff off. Right?
Exactly. Thank you, Keith and Ashley and Mike. I appreciate everything that you guys and gals do for the electrical industry. I know you and a lot of people out there probably don't know the amount of time and personal time each of us put into the industry. And I thank you for that. And I'm glad to be a part of the wonderful team at NEMA. So that's kind of cool.
Great.
Brian Jackson, thank you. Matt Hermanson, thank you. Gravity Mind, which I believe is Brian Holland. Corey Hanna's, thank you. Rafael Velasco, Gravity Mind, Ryan Jackson. Who else do we have? We had Robert from Omaha. Yeah, Robert from Omaha. That's Education Power.
Yeah, Sparky.
And I'm not going to talk about that one.
1600.
Sparky. Yeah. Yep. There's, and Nihad El Sharif was on. Yep. Nihad. And we had, Facebook user. Yeah. It's incognito. Ryan Jackson. So thanks for chatting it up. Thanks for the questions. And Raphael wants to talk a little bit more about classified AFCI breaker. Paul Flager, thank you for joining in. Mohammed, thank you for joining in. So we had a good team out there. And remember, you can go out to afcisafety.org, submit questions or challenges, problems, opportunities, and download a lot of information. Electrical Safety, ESFI.org. Gosh, I got AFCI on the brain. All right. So I'm just going to sign off if I can find my button here. So thanks, everybody. Thank you. Thanks for all of those guys and gals who joined us online and out there. We'll tune in next time we go live. Check out AFCI or IAEI News live as well. So you'll probably see the same crew there as well. So thanks for joining us. And thanks for all that you do for electrical safety, all you do for electrical industry. And remember to be safe and stay healthy. I'm going to stop. Cool beans.
Great.
All right.